Hi, and welcome back to Algebra 1. Our goal for today is continue working with our graphing, and more specifically, graphing linear inequalities, where we have to think about setting a boundary with a solid or dashed line, and where to color in to represent all of the possible solutions of that linear inequality. Please remember, when you have an inequality, you are always setting a boundary and doing a shade. When it's a linear inequality, that boundary is a line, and the shading is a region of a coordinate plane. You have options of how to go about graphing your boundary portion or your boundary line. And my suggestion to you would be to follow these quickest, easiest, simplest ways. So if you have proportional relationship form, that's really slope-intercept form because it has a +0 here always, or goes through the origin. So if you're given proportional relationship form, slope-intercept form, or function notation form, slope-intercept form is your go-to, simplest, easiest way to graph. If you're given point-slope form, the simplest version is using that point and the slope right? This point and the slope here that you know from your equation, your line. However, you can also do slope-intercept, rearrange it into y equals mx plus b, and use your slope and y-intercept to help you graph. If you have standard form, you can rearrange it like all the others into y equals mx plus b and graph, or it's sometimes easier to just use your x and y intercepts, make a quick little table. If you have special case lines of x equals and y equals, if all you have is an x, then you must make a quick little table. You don't have another way to graph that type. If you have a y equals line, you have two options. Again, making a quick table would be my suggestion, but you could technically get it into y equals 0x plus your number format, and then use slope-intercept form. So picking up where we left off in our notes yesterday or in our previous lesson, let's continue with our examples. So number 5, we have the linear inequality. Y plus 5 is every number less than or equal to -4 times x minus 1. Now, we want to pick a method here to help us graph. Since it's in point slope, I would suggest use the point and the slope that you know from that when we make it an equal sign equation or inequality to start. Or again, remember, you could take this and get in this y equals mx plus b and use your slope and y-intercept. If you really struggle with using point slope, then go ahead and take the time to do the rearranging. I'm going to go ahead and do point slope since we should. It is the quickest, easiest method. So we're going to have this y. Remember, we want subtractions here and here. So if we have an add like we do here, we're going to undo that to minus -5, just to help us identify this -5 is the y of our ordered pair of our point we know. And then we have this -4 times x minus 1, where this 1 is the x of our ordered pair. So we know a point on our boundary line is 1, -5. So I'm going to start there. Remember, that's a point or a location in our coordinate plane. It is not our slope. It's not a rise up, run out. It's telling us how to move from the origin. So for 1, -5, it says go to the right one and down 1, 2, 3, 4, 5. And that's the point we know. That's 1, -5. All right, and then we can say, all right, from there, this -4 number here is our slope. So our m value is -4 over 1. Or we can use 4 over -1 to help us move to different locations on our line. So since there's an equals to here, our boundary is going to be a solid boundary line when we go to connect. And so we're going to drop 4, go to the right one. So down 1, 2, 3, 4 over 1. Or we can rise 4, left 1. So 1, 2, 3, 4 over to the left 1 gets us to new places on our line. Up 4, left 1, up 4, left 1. All right, now we're out of room. We want to take our ruler, whatever straight edge, and remember, we have to go past this point and past this point. We're not just connecting like this. That doesn't work. That's not our line. That's a segment. All right, our solutions go on here for ever. So we need to go through our last points. The points are just there to help us connect so that we can draw every possible solution. All right, so since it's an equals to, that everything on that line is a solution. However, there's a shaded section of our coordinate plane that also represents solutions. So we want to know our solutions on this side or this side of our boundary line. Again, my suggestion is using 0, 0 when it's not on the boundary line because it's not here, but you could use any point that's not on the boundary. If it works, we color that side. If it doesn't work, we color the opposite side of the line. So I'm going to test 0, 0. All right, this 0 goes here. That's our x. That 0 goes there. Let's see if it works. 0 plus 5. When we do that addition there, will give us something less than or equal to -4 times 0 minus 1. Now, some of us have been distributing here. We don't need to distribute because we're doing PEMDAS. We're not stuck in here. We can do 0 minus 1, and we can do 0 plus 5. Parentheses first on both sides to get 5. Is it less than or equal to our -4 times -1? All right, 5, is it less than or equal to 4 would be our question. All right, so 5, is it less than or equal to our 4? That is false, right? That's not true. 5 is greater than 4, not less than. So 0, 0 doesn't work. So when we look at our graph here, and we look at where 0, 0 is, that means this whole side where 0, 0 is does not work. So that means this entire side away from 0, 0 represents where our solutions are located. And that's where you're going to shade your solutions. When you're working on your computer, you can go ahead and just draw in some line segments on the side that shows me you understand that's the side that would get colored in with the solutions. All right, number 6, we want to graph the solutions of y is everything greater than -3. We have a special case line here with just a y. When we have just a y, we have two options. Get it to y equals mx plus b or make a quick table. I always like to go to a quick table because it keeps us from making mistakes more. So y equals -3. So if I make a quick table here, all my y's have to be -3s. And my x's can be anything. We've been using -1, 0, 1, and 2. All right, now that we have 4 locations on our line, we can use them to help us graph. To the left 1, down 3 is a point on our line. Don't go left or right, go down 3. Right 1, down 3. Right 2, down 3. All right. Again, some of you have just been connecting those 4 little dots and saying that's your solutions. It is not. All right, no equals here, which means we're setting a boundary here that's not part of our solution. So when we connect here, we need a dashed or open boundary line. So be careful. And it will look something like that. All right, so you don't want too much going on in here, right? We need space in between our dashes. All right, now this point 0, 0 is not on our boundary. So do we shade above or below is the question. All right, so I'm going to use that 0, 0. It's not on our boundary line. Again, if we go up here to our coordinate plane, I could do anything, right? I could use this point here, right? I could test that. 9, 9, right? I could test this point here, right? As long as it's not on the boundary line, we can test it. And if it works, we color it. That's the rule. If it works, we color it in. So if 0, 0 works, we want to color it. So 0, is it greater than -3? Sure is. 0 is bigger than any negative number. So that means our 0, 0 point that we tested is a solution. So we want to color it, right? If it works, we color it. So we want to color this origin spot, right? So everything up here above our boundary line is our solutions, right? It's our side that would get colored in. Again, if I'm working on a computer, I would just take some line segments and show that I'm shading above. That's where the solutions would be located. All right, number 7. Y is everything greater than or equal to 2x plus 3. All right, this is our given to us in y equals mx plus b format. So let's go ahead and use our slope in our y-intercept to help us graph here. So y equals 2x plus 3. Remember, we're doing our boundary line, which is going to be an equation, right? We're taking this sign temporarily and making it equals here. All right, our slope is a 2 over 1, or we can use -2 over -1. And our y-intercept of our line is 3 or 0, 3. All right, so we know this point. Let's start there, which is up 3 on our y-axis. So don't go right or left, go up 3. It's not a slope, it's a location. Now we can use our slope of rising up and running out to get to new places on our line. So we're going to rise up 2, run out 1. Rise up 2, run out 1. Rise up 2, run out 1. Or drop 2, left 1, 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 drop 2, left 1. And then since it's equal to, that means our line we're about to draw is part of our solution. So it's got to be filled in our solid. So we're going to connect here with a solid boundary line. All right, we're not done. We have part of our solutions, right? Every point on that line is a solution, but there's also a region of our coordinate plane that has solutions. So I know up here or down here, where are our solutions located? Again, this 0, 0 is not on our boundary, so let's test it. If it works, we color it. All right, 0, is it greater than or equal to 2 times 0 plus 3, right? This x goes in here. This y value went in there. All right, multiply always before we add. So 0, is it greater than 0 plus 3? Or 0, is it greater than or equal to 3? 0 is smaller in value than 3, so this guy didn't work. 0, 0 did not work, which means I'm not allowed to color 0, 0, which means this guy can't be colored, and down here is not our solutions. And instead, this direction up here is our solution. So I'm going to take my pen or pencil. That's our side we should be coloring. That's the side with all of our solutions. If I'm working on a computer, again, I could just draw in some line segments here to show the solutions. All right, last one for right now. We want to graph our linear inequality. Y minus 3 is greater than 2/3 times x minus 2. All right, we're given our linear inequality here in point slope format. So I'm going to use that as our graphing method. I'm going to use the point and the slope I know from that equation. The point here of what's y and x, right, are going to create an ordered pair x comma y, and our slope here to help us move. Now, if you have a hard time getting that point from point slope, take the time, rearrange it to y equals mx plus b, and use slope and y-intercept. If that keeps you from making mistakes with your boundary line, then do that. I'm going to go the quicker, easier method of using just this point slope. All right, remember, point slope, these are always subtract, so we're good. We don't have to rewrite anything. Here's our y, 3. Here's our slope, 2/3. And here's our x, 2, right? X, m, y. All right, so our ordered pair of x comma y. Remember, this is not a b. B is used to represent a specific point, which is the y-intercept. This point of 2, 3 is not a y-intercept. Y-intercept has to be a 0, something. So we can't use b here. So just x comma y, or a point we know is 2, 3. So when we go to our graph, remember that's not the slope. It's giving us a place in our coordinate plane, which says go to the right 2, up 3. That's a spot we know on the boundary line. And then from there, we can use that m value, our slope value of 2/3, or -2/3 to get to new places on our boundary. So rise up 2, run out 3. Rise up 2, run out 3. Or drop 2, go left 3, drop 2, left 3, drop 2, left 3, drop 2, left 3. Now, there's no equals here. So when we go to connect our points that we're going to use to help us create our boundary, that line has to be dashed or open. All we're doing here is setting a boundary. And it's going to look something like so. And make sure you go through those dots all the way on forever with arrows on the end. Our boundary stretches forever. So technically, we have graphed nothing yet. All we've done is said, here's the very, very, very edge of where those solutions are going to start and end. All right, so we want to know, are the solutions up here or down here? Again, this 0, 0 is not on our boundary. It's an easy one to check. Let's check it. All right, 0 minus 3, right? I took this y and I plugged her on in. Is it greater than, don't forget that question mark, 2/3 times, I'm taking this x, I'm substituting in 0 minus 2. All right, PEMDAS on each side to see if we get a true statement. So 0 minus 3 would give us -3. Over here, we have multiplying with parentheses first. So 2/3 times, and then 0 times or minus 2 would give us a -2. All right, -3, is it greater than -4/3 or -1 1/3 or -1.3? However you want repeating, however you want to write it. All right, so is -3 bigger than -1 1/3? Although it looks bigger because 3 looks bigger than 1, remember in the negatives, as our digit looks bigger, it's actually smaller in value. So this is a false. We need to slash that, which means 0, 0 did not work, which means I can't color it. Right? I'm not allowed to color 0, 0 here. So I'm going to go up here and say, well, that guy didn't work, which means down here, this whole side doesn't work, which means up here is where our solutions are located. And I'm going to have to color that entire side. And so our solutions would be every point above the boundary line. All right, I hope that helps you attack your work. See you guys later.